Hi, Srini garu.
Hi Surya.
Hello, sir.
Good evening.
Good evening.
Yeah. Just let us wait for few more
Some
people.
other members. Yeah. Definitely.
Good morning, Abhijit.
Good morning, Srinivas.
How are you doing?
I'm doing good.
Okay. Is someone joined? Like, hey Trida. I'm just waiting few more people to join. I'll start in 2 minutes.
Srinivas, Mallikarjun join.
Good evening, Malli, and good evening, Purna.
Yeah, good evening, Srini.
Good evening.
Yeah, this session is there for half an hour only.
Actually, I planned for 1 hour, but however, I try to finish in 45 to 50 minutes because I have another call.
Okay, no
yeah,
problem.
yeah.
Is going to be a daily training session, Srini, or
Yeah, I'm just planning for a daily session only because I want to. I'm planning for 45 days. So daily, I'm planning for the same time. And so I need to check. But let us first go with this first session, and I'll just get some feedback from others. Like, so how it will like only weekdays or it's okay for even weekends. We will discuss on that.
okay, sure.
Yeah. Okay. So welcome to the MLOps engineering training. My name is Srinivas, and I have totally 15 years of IT experience, where I have worked with multi MNS companies like Wipro, Polaris, and also with Citibank, Mastercard, and BNY Mellon. And I'm currently engaged with Mizuho, a Japanese bank in Singapore, where I'm currently working as a lead data science and MLOps engineer. I'm working with anti-money laundering department here and providing them in data science and data engineering solutions, where my focus is more into transaction monitoring and customer due diligence teams. So I just go with a round robin. Like I just want to know about each of you. Like, can I ask Abhijit? Can you please just give a brief introduction about you?
Sure, Srinivas. So my name is Abhijit Mahapatra. I have like 5 years of experience into data science, and I've worked with companies like Accenture, KPMG, Altron, and VNurture based in India and in France. Currently, I'm a graduate research assistant in Texas A&M University, and yeah, I'm looking for more into the ML ops and data engineering side, only than data science. So that's why I'm in this course. Thank you.
Yeah, nice, very nice. So welcome to the training. Yeah. Next, Mallikarjun.
Yeah, Srinivas, yeah, this is myself, Mallikarjun.
Yeah.
So I have 10 plus years of experience. So currently I'm working in Citibank. Okay. So I don't have much knowledge on this database and everything. So currently I'm working on a different platform. Okay. So I wanted to, I am interested to learn this machine learning and data science. So due to that I have joined.
Okay. You don't have any knowledge in machine learning.
Yeah, I don't have any knowledge.
Okay. No problem. Okay. Next, Purna.
Yes, Srini, this is Purna here, and I have 12 plus years in IT experience.
Okay.
Currently, I'm working in Citibank, and I am in a different technology, which is currently I'm working. I don't have much knowledge. I have some concepts. I know there's some concepts on that machine learning or something, but I don't have much experience on this.
Okay. No problem. You learn something from this training. Okay, Surya, up to you.
Hello, everyone.
Yeah.
My name is Surya. I'm working with CRISIL currently. So I have been working in this model development and the model validation from last 5 to 6 years, and but I was not in production side. So I'm more curious to learn about how to build these models into the production. And even I worked on data engineering side, but now I'm interested to learn this MLOps because I want to cover these 4 areas.
Okay, you have knowledge in data science, right?
Yeah, I have the knowledge.
Okay, that's cool. Manoj.
Thank you.
Yeah, thank you. Manoj, over to you.
Yeah, hi.
I can hear. Yeah.
Yes.
So, want to know like your a basic introduction about you.
Okay. See, I'm working as an RPA consultant, wherein I'm using a few of these what we say ML concepts for intelligent automation purpose. So I just want to know how this, apart from being this ML automation, what else comes into this product life cycle, especially when it comes to machine learning projects. So I wanted to know a deep insight about it. So I thought I would enroll into it. So I'm just looking forward to learn from this.
Okay, yeah, sure. You will learn definitely something from this training which you are looking for.
So I'm pretty much keen on it. So we'll see how it progresses.
Yeah.
Work on it.
Okay, sure.
Yeah.
Okay. Thank you all for your time and giving some introduction about yourself. And without waste of time, let us go with today's session. Like, let me share my screen. So, like, so MLOps. What is this term? Why people are running behind MLOps? So, who are working in this data engineering, like database programming? So you people, whatever you do, right? That is actually like even in the database or ETL or big data, wherever you will work with data, right? That is data engineering. But coming to like data science, right? Is just like we use the existing data and do some analysis on that. So here, data scientists, I can say what they will do, like they will work on the existing data, historical data, and do some analysis and provide some insights on that. But they will take the help of data engineers. So coming to MLOps, right? So it is like I'll not go directly to MLOps. So what is my agenda for today is like I want to go with what is MLOps and what is the motivation of going with MLOps, and what are the solutions and future trends in MLOps and MLOps components. Components means what are the different components in MLOps and different roles involved in MLOps. So how to like successfully deliver a project using MLOps, and what is the machine learning life cycle, how it will be like, and what is like MLOps and difference between MLOps and DevOps, and what are the major phases in MLOps and the different tools which can help to go with MLOps to implement MLOps, and MLOps maturity model levels, and what are the stages in continuous integration, continuous delivery. So but I'm not going to cover all this, but I'll go with some of the like topics today and try to give some insights about each of these. So what is MLOps? So as you know, like you heard about DevOps. So DevOps, if you are not sure about DevOps is nothing but it is a culture with set of tools where a project will be delivered with continuous integration and continuous delivery. So DevOps means we will use some set of tools. For example, I can say like there are so many tools in the market for like implementing DevOps. I can say like Ansible is one tool, and we have like Kubernetes, and we have Jenkins. All these tools, right? They will help to like provide or deliver a project end to end with continuous integration and continuous delivery. What is this continuous integration and continuous delivery means? So whenever you deliver a project, you follow the SDLC life cycle. So here what will happen is, right, so earlier we used to do manually all this kind of like for example development or analysis or development or testing. So all these SDLC we used to do manually. So this DevOps tools is helping us nowadays like to automate everything and to integrate all these sequence of steps using one single pipeline and they deliver the solution at at once. So DevOps it was a hot skill in the market now, and MLOps why it came into picture is, right, you see here MLOps is actually is a combination of these three: machine learning, DevOps, and the data engineering. Data engineering means some of the people like for example you already working on this database engineering, like you use database and you do database development, and some people work on big data. Like big data means they do some ETL on big data. They will like pull some data and they do some data ingestion and they do some transformations. They load the data into some target. So this is like
pipelines.
Yeah, data pipelines. So these are like data engineering. So machine learning means it is like just like applying some statistical like techniques or modelings to on the data and get some meaningful insights from that and take some appropriate decisions on that. So DevOps is a culture which will set of practices, I can say, which will aims to deploy and maintain the products. So on the combination of these three, a MLOps set of practices came into picture. And if anybody will ask you like what is MLOps, you can say it is a combination of machine learning, DevOps, and data engineering. So there should be a coordination between these three groups, and then only this MLOps objective will be met. Because if you go to any project, right, any data science project, a data scientist may need some data, right? They will depend on data engineer, and the data engineer will provide some data, and data scientist will work on that, and they will develop some models, and to deploy that model, right, the data scientist may not have that. He has to coordinate with operation people, where DevOps people will come into picture. So sometimes there will be a gap between this data scientist and DevOps people, operation people, and they will get some like miscommunication, and the most of the data science projects were getting failed. So 90% of the projects were getting failed which are not even used to deploy in the production. Then people started thinking about what is the solution. Then they started integrating this machine learning, data engineering, and DevOps, and they came with this MLOps culture. So data engineering and DevOps also people are using combinedly now called as data ops. So data pipelines with continuous integration and continuous delivery. So some people are looking for, like, if you see in the market, you can see AWS data engineers. They use AWS DevOps engineers. They do some data engineering in cloud. They use this data engineering and DevOps for that. We have openings for that also. AWS DevOps, Azure DevOps. These are called data ops. But here what we are talking about is MLOps, machine learning operations. That is data engineering operations, which are these two combinations which I was telling. Combinedly, yeah.
So nothing but like if MLOps is a combination of this DevOps and data engineer, right? So we need to know
the
about
culture. You can say,
yeah. So we need to know little thing about these two programs as well, or
you should know what you require. You should know whatever that is required to fulfill your tasks with respect to machine learning, and what is the level of data engineering you should know, and what is the level of DevOps you should. It is not like you should be a full stack DevOps engineer. You need not like a full stack data engineer. It is same.
So basic things we need to know. Like
you should know, right, what is happening. If you want to integrate, if you want to connect the dots, you need to know. You should have some knowledge about these tools. There are some tools. It's not like you should know all the tools. There are some tools which will fulfill this set of practices, and we should know those tools, which we are going to discuss in this training. So how to use those tools on appropriate, how to find out which tool is we have to use at which stage. So for example, for machine learning model development, I use Python. For data engineering, I can use some tools like Spark, and I can use for scheduling the jobs. I can use Airflow, and model versioning, I can use Kubeflow. Data versioning, I can use DVC. There are some tools. I'll discuss all those things going for in the upcoming sessions. But for now, we just keep in mind that MLOps is nothing but it's a combination of machine learning, DevOps, and data engineering. This is
okay. Okay.
So next, what is the motivation of going for this MLOps? So as I mentioned, right? So most of the people to deploy the models in the production, to operationalize these ML models, these data scientists need to work with multiple teams. It's like they have to work with business teams. So they have to understand the business and the data engineering teams, and they also need to work with operations teams. So business teams means the first responsibility of any data scientist is to understand what they have to achieve, what is the goal of the project. So that they will come to know only after discussing with the business. And engineering means they'll go with for example, data engineering team. What are the data required for my like machine learning project? So so they will go and reach out the data engineering team. They will collect the data, and they will try to provide the data to data scientists. And then once after they collect the data from the data scientists will collect the data from this engineering team. They start working on this data analysis, and they develop the models. They build these models, ML models, machine learning models, and they will provide these models and take the help from the operation people to deploy the models in the production usually. So this is what they have to do, but this is not happening because there is a gap between, because operation people may not know about machine learning, right? And data engineering people it is not mandated that they should know about machine learning. They don't know what is the machine learning, how to deploy that. So this gap was there earlier. Now people are trying to overcome that gap using this MLOps, like how to integrate this machine learning and data engineering and this DevOps. So all these set of practices, and they are trying to overcome this. So that is the reason why people are running now motivated and going behind MLOps. In with respect to machine learning. And even the organizations are now, if you see in the market, right, most of the people they are looking for every data scientist should know this like DevOps tools also, like Kubernetes, Docker, and Kubeflow. There are some tools because they want that people who are ready to deploy the ML models in the production, because there are no people to deploy the models in the production now. There are so many tools to you that will help to deploy the models in production, but there are no people how to use them. That is the reason. Maybe there are DevOps people are available, but they don't know what is machine learning. And data engineering people are there, but they don't know what is machine learning. At the same time, data scientists may not know what is about data engineering, how to deploy the model. Deploy the model in the sense integrating the ML model outcome with the product. For example, maybe for example Amazon recommendations, right? You answer whenever you go and buy something in Amazon website, right? You will get some recommendations. So those are like real-time I can say analytics, where in the background a machine learning model will run and give some recommendations to you whenever you buy something. So at the same time, people are most of the data scientists does not know how to like deploy the models in the production. They stop at the development itself. That is the reason most of the data science projects are not going into production. Now the goal of MLOps is to streamline those challenges with this set of practices, and also like MLOps will bring like agile process into data science projects, because data science projects are not like normal development projects, because they are R&D projects. So most of the data science projects will take so much time, because every data scientist will work 80% of their time in data preparation only. The model development will take at most 1 or 2 weeks. 80% in data preparation, 20% in model development. Okay, so that is the reason people are running behind. They want to like streamline this, and they are trying to get this MLOps and agile processes into these data science projects. And if you see here, there are many here, if you can see like ML code is there, and data collection is there. Feature extraction means extracting the meaningful columns, I can say, in database perspective.
Variables.
Variables, I can say variables from the data. Which variables are required for my ML model, and what are the like analysis tools? What are the like data verification tools? What are the mission resource management? These all like come into picture in MLOps, because there are so many things which we need to consider when we are deploying into production. Whatever you do in development, right? So that is like I can say like a sample. If you go to production, you will find the real data, and there you will find the difficulty of like how the model will give like the results. The ML model means a predictive model which will give some results based on some historical data. For example, assume that my requirement is to identify or predict a credit card transaction is fraudulent or not. So my goal is to like whenever a credit card transaction is happened, my model should go and predict it is fraudulent or not. So in real time, for example, that is the volume of data very high, right? So we should be in a position to even manage the data, and we need to manage. My model should be able to work for a large volume of data. So to manage that data, as well as I need my infrastructure should be also very high end, right? My model may work with a small amount of data in development very well. It is not like my model will work better. The same model will work better in production, because production data is real-time data, right? So that is the reason why MLOps is people are running behind MLOps. So there are some challenges where why MLOps came into picture. Like for example, whenever we deploy a model, right? So most of the data scientists, they are unable to deploy the model because model drift will be there. Model drift in the sense, whenever model will be changed, you change the code of the model, for example. So that will give some that the results will be like the model, whatever the results the model will give, like it will be degraded. So degrade the model performance because the model may not understand the new feature, right? So for that to overcome that, in this MLOps culture, we use a feature store. We reuse that feature store. We store all our features in the feature store, and we try to use that feature store in reuse that feature store in our future models and current model. So there are some tools already available to store the features, in the sense variable storage. So earlier there are no such kind of storage. So we have to rerun the model. We have to find out which variables in the data given the best results. So these all are matters in data science project. So which features you are selecting, which variables you are selecting in the model, which variables, after I selected some of the variables, so my model given very better results. So next time I want to find out which variables has given best results, right? So there are no such control over that. So now feature store is one of the tool which will help us to store the features. At the same time, we have data version control tools which will help us to find remember that which data has given me best results. Just like you know about Git, right? Where we go and do some version control for the code. Same like that, now people are using data version control tools where I can store the data, multiple versions of data, and I can reuse that data for different experiments. Experiment means whenever you run your like ML model, right? You do some experiment. Experiment in the sense you try to get some results about your model. So model experiments also we can store in a data in a storage area, and that is called model versioning also available. So we have to do model versioning, we have to do data versioning. At the same time, we have to store the features. So this all are not possible earlier because
sorry for interrupting.
Yeah.
Can you please let me know again on the data versioning and why we need to do this?
Data versioning we need because you run your ML model and multiple times, right? To see what is my model accuracy or like accuracy, for example. So to store that, like to assume that I want to find out which data has given me those best results. So for that we have data version control tools like DVC, where I can give some versioning for my data also, just like how we do code versioning in Git, right?
Yeah.
So same like that, we can even go for code like version control for data also. So that will help me to like which data has given me the best results, for which experiment has given me like best results. That also I can capture. So for that, we have DVC for data version control, and Kubeflow or MLflow. These tools are helping us for even tracking the experiments, and also like model versioning the models also, like which model, like for example, assume that the model which I have executed 1 week back, for example, I don't remember. So it will have some version, right? So which has run like and given best results, and also like which data has given me best results. So I want to track that, right? So I can use these tools like DVC. I can use like MLflow, Kubeflow, and also like to automate these pipelines, we need some tool, some orchestration. For that, it is not easy to manage if we have large amount of data and we need to have infrastructure, we need to manage resources. So for that, we have like Kubernetes is one of the orchestration tool which people are using now. And so these tools are like part of DevOps, right? Kubernetes, Docker. So earlier, like we don't have any containerization. Containerization means combining the packaging your program and packages, all this. But now we have Docker, which is helping us to like package your code and deploy in production. Like for example, using Kubernetes. So you can perform all these activities just like DevOps in with respect to machine learning also, right? So here if you see, right, here it is showing like develop your or experiment. Like it will not take much time, right? For data scientist, it will take within for one data scientist weeks. But you see, right, this second one, this one will take so much time, right? Like how I need to find your dependencies. So assume that your ML model or program is running good in your local. Right? It may not work same way in others' environment. Maybe their environment does not have that all those packages where they need to install all those packages, Python packages, for example. So this package is nothing but example. Docker will help us to package your model and also like
what
are the
code to containerization.
Yeah, containerization, correct. All this like containerization, all this we can build that and we can use it once using. We can create a Docker image and we can deploy in this Kubernetes cluster. And we can use Kubeflow also, like for building the pipelines, ML pipelines end to end. And also load balancing also matters because it is not like your infrastructure should support if you have you don't have enough resources. It may be it may be shared by other projects also, right? So you need to have maintain and balance the load, and also data also should be like divided and used, and also hyperparameter tuning which you do for ML model. All these should be taken care, right? So there we need some tools to do that. It is not like we can do right away. And again, we need to the model you have to which you tuned using this hyperparameters means we use hyperparameter parameters to so that we'll tune them so that my model will give better results once after you develop a model. So if you want to get better results for a ML model, we use hyperparameter tuning and set some parameters to get better results than the existing results. So that also matters here. Tuning, like how to go and parallelly run your models, multiple models, and combine them and get the results. And also like monitoring. So how you are monitoring your ML models, that also matters, right? It is not like once you deploy your model, you should leave it as it is. You should know how it is performing. Is there any change in the data? Is there any change in the like variables like features? Any new features got added? And also like how I can automate this process, like where I should have the continuous integration, continuous delivery. And if you come, this is CI/CD will come only in DevOps. If coming to like machine learning, you should have continuous training also. Along with the CI and CD, you should have CT also. So how to overcome all these challenges? So that is like where MLOps will solve your problems. So data challenge which I was telling, like development data is not and the real level data will not be same, right? So in development where you work in your like ML models, just like in Jupyter Notebook, so it will just like you will get better results. It is not like even in production also it will work like the same way. So you work on sample data on CSV files and you work on Jupyter Notebooks and use some AutoML tools and train your models, right? So it's not same way in production also, right? And also like data changes in production will degrade the model performance. Whenever there is a change in the data, that may reflect your model, and your model results may go down, may not give the correct results which we are getting earlier. So you have to monitor continuously, and you have to check my model is giving the better results or same results, and is there any changes is my model performing in the right way, or it is giving different results compared to the previous results. We have to monitor that also. So that also one of the key thing which MLOps will help. The solutions and future trends, like, so these are some of the like structure which I can say. If you see here, right, we need a scalable production ready platform, data science platforms, I can say, which and practices from day one. It is not like for development to use some set of tools, and for production some set of tools. So we should have a same kind of platforms like for development, UAT, and production, so that we will follow the same set of practices in every stage. So you see here, right, a data engineer will be here, and a data scientist job will be here. So coming to where DevOps and the data scientist should coordinate, they have to do this one. Let me increase the size. You see here. So if you see data scientist, data engineer will go for data acquisition, and it will move to some exploratory data analysis, where data scientist will work on this area in a data science project. So once the business objective will be made, then we'll go for what is the data required for this project, and that will be done by data engineer. From there, it will go to data scientist, and the data scientist will then take this data and develop the model. This is the cycle, model development life cycle, and then he will come to DevOps. DevOps means operation people, where he will work with operation people to perform all these activities. So data engineer, DevOps. Data engineer, once again, from here he will come, he will involve here also. So he will help in like he can go with like data ops, I can say. So continuous integration of like extracting the data, loading the data, transforming the data, loading the data. So he will involve with operations in those stages. And ML architects and the data engineers will be work here, where they have to like check the model performance and the risk assessment, and also monitoring the runtime environment. All this will be done by ML architects here. So these are the different roles which I can say, like a platform. I can say this is the platform, unified platform, for example, where development, UAT, production all should be in the same way, like here. Okay.
No, you mean to say like the current model they're following? Okay, can you go to the previous slide? Yeah. So this is the current flow that they are following, correct?
But there is a gap between these two people here. There's a gap between these two people here. There's a gap between these two people. So this is it. Whatever it is showing here, it is not working like this way. So the data engineers will not properly respond to data scientists every time.
Okay.
DevOps may not respond to data science because they don't know what is data science, right? What is machine learning? So there should be a coordination. So MLOps will help to fill this gap, so that if data scientists know what is like DevOps, basic knowledge of DevOps, so he can work with DevOps guys and during this deployment. In the same way, data engineer will have some set of some knowledge about data science, so they can interact with data scientists. So now people are expecting that in each company, if you go for data engineer, they are expecting data engineer should have some knowledge about machine learning and all. And also like data engineer and DevOps. Data engineer earlier, if you know, you will work as in database as a data engineer only, right? So you may not have knowledge about DevOps. Whenever you want to deploy something, you need to coordinate with this DevOps people, right? So now after DevOps culture came, people are following that. Before that, there was no such culture, right? The same time, this DevOps culture now people are implementing in machine learning also, to overcome these challenges of deploying the models. Now DevOps is already, people are practicing this culture, right? So it is already running in the market and people are using in their projects. But this DevOps culture is not yet implemented in this data science projects. Now people are trying to incorporate that and fill that gap. That is called as MLOps now. It's a combination of machine learning, DevOps, and data engineering. They're combining all this. They are making these three areas to coordinate each other and provide the solution and get the success of the project. Because 90% of data science projects are not success. Only 10% only. If you see, if you look back, now people are using these tools and successfully delivering the projects.
Okay, so nothing but like MLOps, MLOps is doing all these features and giving the data to these people, right?
Not data, I can say they are getting success of this data science projects now.
No, okay.
I'm successfully delivering the projects, I can say.
Okay.
Yeah. So this is like what are the different life cycles in data science here, like. So use case means what is your data science problem? What is your problem? Like I want to predict the credit card fraud detection, right? So that is the use case. I can say use case discovery means. From there you go to data engineering. This is a traditional life cycle of I can say any data science project. Use case we'll first try to finalize and then go to data engineering, and then we'll go to machine learning. We'll develop a model. This is there where ML model will be developed. This stage. In this stage, we'll collect the data for the project and do some data preparation. So because ML model expects the data should be with in some format. So we have to do some data preparation, do some data transformation, and make the data ready for this level ML model development stage. So that will be done in data engineering. Once after this this is done, we'll come to ML pipeline where we do model training and testing, and we'll go to production deployment. And once it will go to deployment, then we'll monitor that the model also, like just like how we monitor your regular normal projects. So you go and deploy your product, right, and then you monitor that, right, continuously how it is working. The same way ML model also is just like a program. We can say like we deploy this and then we'll try to monitor that in the production. That is mandatory. So because we have to monitor how my model is working in production. So this is like use case discovery, how it will be done. Like we'll try to understand the business, because if you go to some new domain, right, assume that you from banking you move to supply chain. First you need to understand the business, right? So that is called business understanding. So once you understand the business, then you'll try to get some use cases in that business, and then assume that in banking itself you joined in a banking project and you want to find out some useful use cases in that project. You try to found that credit card fraud detection is one use case. So that is where use case identification. And then you try to collect the data for that use case. Like credit card fraud detection means you have to extract all the credit card transactions of the customers and you try to understand whether the data is sufficient for my project or not. That is data understanding. Is the data sufficient? Do I need to go for additional data? And what are different data sources available? All this will be done in data understanding. And then we'll see feasibility study, like whether my data is readily available for my analysis. So this will be done in this life cycle. Then we'll come to this stage where, so these two stages will be here, and this stage will be here. This ML machine learning pipeline, data preparation, algorithms, like developing the machine learning algorithms, model building and training your model, and experiments. So you try with different ML models. In machine learning, we'll not use only one method. We use different methods for our use case. So we have different algorithms. We use them and we'll try to experiment and see which model is the best one, and then we'll evaluate that model. Finally, we'll select one, and we'll serve the model. Serving the model in the sense we'll try to make the model ready for use. So that will come once after the model is ready for the serving. We'll come to this stage, deploy the model into production. So deploy, and these two stages will be here. After the deployment, we'll even monitor, right? So we'll come to deployment, automate, operate, and monitor and optimize. We'll try to improve the model. Optimize means we are trying to improve the results. So this is a life cycle. Everything is a life cycle here. So this will be achieved through using MLOps with CI/CD and CT, continuous integration, continuous deployment, and continuous training. DevOps, we use continuous integration and continuous delivery, CI/CD. But in coming to MLOps, we got one more additional thing called continuous training. So you have to continuously train your model so that the model will learn continuously and give the best results. Okay. So MLOps, like which I mentioned, right? You see here, MLOps CI/CD pipeline, which I mentioned, data pipeline, environment pipeline, ML model training pipeline, testing pipeline, and deployment pipeline. This will be like just like all are in CI/CD. These are like just like normal development project where we use DevOps, but here we are using in MLOps. So we use a data pipeline where in data pipeline we collect the data, we try to transform, where we do in ETL, right? ETL, what we extract, transform, upload. So that is like data pipeline only. Collect the data, do some transformations, and load the data, and do some data preparation, all this kind of stuff. So we do in data pipeline. So environment pipeline also, like which checking whether my environment, how it is working, like in development. And then ML model training pipeline is, right, where my ML model using this data, right, how it is performing, like in development. Usually we do that in traditional data science projects. But in case of MLOps projects, right, it will be just like the whole, these steps are like automated. But currently people are doing manually. This will be individually, separately they do this one separately. Every pipeline is independently they do, and then they will combine them. So there will be some gaps in between these pipelines. So MLOps, it is helping to connect these pipelines and automate this to run in like one by one. Okay, so data engineer, he will be involved in data pipeline. Data scientist will be like in ML model. IT software or engineer, so they will help in some development. Tester, they will try to help in testing also. There are no specific testing people for data science projects. The data scientist only will do the testing. Now people are expecting, there are jobs for MLOps testers also in the market. Big data testers are there. So the same like that, there are no specific testing engineers for data science projects. Now people are expecting some people even in testing side also. Like for example, there are jobs for MLOps testing engineer. And operations people is nothing but who will help us to deploy and monitor the ML models in the production. So these all will be. Yeah,
I think the same people are doing the testing, right? So data engineers
are correct. Yeah. There is.
Maybe
people are
maybe due to
companies are.
Yeah. Maybe due to that reason, like 90% of the projects are not going successful.
Maybe. So that is one of the we can't select data science people. See the results, whatever they get in development, right? You cannot assume whatever you do in development, you will not rely on that, right? You will go to EAT and you can go to
correct.
So same way you have to rely. You cannot rely on this development, right? You should have development, UAT, and production also.
Yes, correct. That is definitely there, but everything like from our perspective.
That is now people are now trying to implement in even data science projects also.
Yeah, if I'm implementing the code, so from my side, everything looks good only. So if someone is doing that only, then only we can able to know what is the wrong I am doing it.
So
that only.
Yeah. So but in normal development projects, people are following that. But in data science projects, there are no such practices. Now
Okay.
people are using these practices and trying to get their project delivered successfully in production. That is where MLOps is coming into picture.
Okay.
Okay, this is like a traditional machine learning lifecycle will be like which I already mentioned, right? Framing the problem, business goal, get the data which is required for my problem, and develop the ML model, deploy the model, and monitor the model. So these pipelines now, earlier people used it to do manually. Now this is also, we are automating all these steps. People are doing independently each step. Now people are automating these steps using MLOps. So this, I don't want to go in detail. I'll share this PPT just to go through it, because this is like how like continuous integration, continuous delivery will be in DevOps, and in MLOps we are just adding CT, continuous training, so which is required. So continuous training means my model should be trained continuously. Whenever I get some data, or whenever I get some data, my model should get the data and trained automatically. So that's what the main intention of this PPT, like how it will be like in MLOps. We add a continuous training because automatically identifying, sorry, yeah. So continuously, how I can train my model is like, there are example feedback loop one concept is there. Whenever I get some data, right, my data get refreshed, my model will automatically get trained on the data. For that, I need to use feedback loop one concept. I will explain that going forward. I don't want to give now itself what is like. I don't want to confuse you. So coming to DevOps, we use CI/CD. So coming to MLOps, we use additionally CI/CD and continuous training extra here. So this is like step by step in MLOps what we do, like framing the business problem, and we try to find out which are the key features or key performance indicators for my model, and what to do, what are the business objectives, and so we try to find out what are the different challenges, like data available or not. We'll take some decisions. So if data is not available, where I need to get the correct data, and is the data whatever available, that is reliable or not, and where I can find, and is there do I need to prepare any data pipeline to get this data and pre-process this data and load the data. So all this will be done. This will be like challenges in data science projects. So data preparation and processing, so which is a part of data engineering actually. Data engineers will do. So now we have a provision to build a data pipeline and continuous, like we can, there are people are using cloud technologies now to create these data pipelines. So we can even use big data tools to create these data pipelines. We have Airflow, we have Apache Beam, which will help us to create data pipelines, where we can load the data, transform the data, and then like extract the data, transform and load. So that I can perform using this complete data pipeline using Apache Airflow or Apache Beam. So that we can automate. My platform should have that provision. That's what this MLOps will help us to integrate. And model training and experimentations. So model training and experimentations, so that we have data version control, and we have Qflow, which will help us to do and track the experiments, which experiment has given me the best results. So these are like, which if I tell now, it will be like confusing. I don't want to tell. And also like building ML pipelines. These are like step-by-step process which we need to go. So today I don't know, just want to give a high-level picture of what is MLOps, why we need to go for. When the job market is very hot now, it is very good in overseas compared to India. If you go to Europe, I am getting the calls and emails per day, 3 or 4 emails from overseas compared to India. So because the market is very hot now, people are looking for MLOps people because there are no people who knows a combination of these skills like data engineering, like big data and machine learning and DevOps. So because DevOps, if you see in the market, right, DevOps people may not have knowledge about machine learning, and machine learning people may not have DevOps knowledge, and data engineers may not have ML knowledge. So people are expecting and very having huge demand for the people who knows all this, have knowledge on these tools like combination, and who knows these MLOps practices. They have huge demand and very good pay in the market. And so these are some of the tools which you can see, like MLflow is one tool which is open source, and where I can track my models, I can store my model, and can even deploy my model. So all I can perform using MLflow is one tool, open source tool. And Kubeflow also one more tool where I can integrate Kubeflow with even Kubernetes directly. And for the version control, we can use GitHub, and we have GitLab and Azure DevOps, and also DVC and CML. These are for version control. And even if you want to do machine learning in cloud, right, AWS, we can have you can use AWS SageMaker, and Azure said you can use Azure machine learning. And coming to Databricks, also the platform is helping to do end-to-end solution. So if you go with Databricks, you can do everything end-to-end in Databricks itself environment. It will not even come out. And we can even integrate Databricks with Azure. We can integrate Databricks with AWS also. So even those people also have huge demand. So this level of maturity I don't want to discuss today because it will be too high. I will discuss in next class. So anybody have any questions? I just want to give some time for that. Time for questions.
As of now, nothing from my side. Srini.
Yes, I have two questions. So you said in the process of deploying, then we should know the few of the tools like Docker and Kubernetes, right? So in this course, are you going to cover the Docker?
Yes. I will cover Docker and Kubernetes both.
Cover means end to end or only high level?
No. No, not end to end. Whatever that is required for this like MLOps, I'll try to cover all that. If you go with I need to cover all full, right, it will be become a DevOps session and DevOps training. So I'll try to cover whatever that is required for this MLOps. I'll do that. If you want more, I can give some resources also.
Okay. And this course, I mean, frankly, we don't know, till now we did not work on MLflow side. So we don't know how it works in the production side. So so as a MLOps engineer, we should know end to end, or it's just enough to have an idea on it. What do you say?
See, if you know, that is better because you have some knowledge. It is not like if you go outside, companies are expecting they may have different teams. So if you go to bigger MNCs, you have different teams. If you go to medium-sized companies, people expect you to do that, right?
Yeah.
Right? So in such cases, you cannot rely on others, right? So my advice is you do one or two projects end to end on this. Then you'll get to know like how to implement this. That is enough. Then later, if you go to some you want to go and implement in some projects, right? Then you can learn ongoing. I advise even go with if you are keen to be in this MLOps for some time, right? You go for some certification, right? Kubernetes developer certification. That will help you to even like get familiarized and get some exposure. If you are afraid of like whether I can learn this like Kubernetes, do I need to know more? Means if you know more, it will be definitely like value added, right? You will confidently work on that project. It is not like you'll get afraid of that. You should like keen to learn it, and because I am also very new to this MLOps when I started. So I started learning it, and I now I know something like I implemented a few projects. Then I am very confident on that. So you will also be in that stage after some time. Don't get afraid of that. Whether I can learn this, and will it be difficult for me in the future, whether I can implement any projects using these tools, and so don't worry about it. You start learning, and one by one you will learn. I'll help you to teach you how to go step by step and do whatever I do. You do some assignments, do that, and you will get familiarized, and you'll get some confidence, and you will definitely feel good after this course. Okay. Don't worry. Any other questions? Abjit?
Yes, Srinivas. Yeah, my expectation from this course is to learn more about the deployment part and the pipelining to automate from the data ingestion to when you're doing any kind of model inference, or let's say retraining approaches. So as long as that will be covered, I'm good to go.
Okay. Cool. We'll cover that. Definitely.
Yep.
Okay. Thank you. Don't worry about if you don't know about anything. We learned everything from when we started as a kid. We learned so many things, right? Feel that you learn something like that. You don't know how to talk, you learned it. You don't know how to walk, you learned it, right? So you learn this also same like that. Don't worry. Thing is possible. This is not rocket science. It will be. So many people are already working on this. It'll be easy once you start working on it. Okay. Okay. Sure. So I'll try to stop this for today here, and can we have a session tomorrow? Are you people ready? So I'll continue tomorrow at the same time if you are okay.
Yes, Srinivas, I am okay.
Fine,
This is
fine.
Mallikarjun. Yeah, this is Mallikarjun. I'm
Okay.
fine.
How about others? Abjit, you are fine, right? Same time tomorrow?
Yeah, fine, no problem.
Okay. Maybe. Okay. Purna, I think you are also fine.
Yes.
Right?
Yes.
Okay. We'll meet tomorrow at the same time. Huh? I'll share this PPT in the group, and I'll share the Google Drive link. Okay.
Srinivas, Sunday class will be there, or Sunday like holiday?
I think Sunday, let us take a holiday.
Okay, great. Yeah,
Okay,
that's what
okay.
I'm thinking.
Yeah. Okay. Thank you, Allah. Thank you for your time.
Yeah,
huh?
thank
Okay.
you.
Thank you.
Srinivas.
Bye.
Yeah, thank you, Srinivas. Yeah, bye.